Exam 5, problem 6. Velocity of proton emerging from Van de Graaff accelerator is 25% speed of light. What is the proton's wavelength? What is the proton's wavelength? Alright, so when we think of proton's wavelength, we think lambda equals h over p, the momentum, equals h over gamma mv. Alright, and gamma is in this case 1 over the square root 1. Well, it's always 1 minus v over c squared. In this case, v is 0.25 c, so this is 1 over the square root of 1 minus 0.25 squared. So let's figure out gamma real quick. Equals 1 divided by the square root of 1 minus 0.25 squared. So gamma is 1.03. So we're 3% relativistic, right? Basically. 1.03, we'll call it 1.033. 1.033. That's gamma. So lambda then is 6.6626 times 10 to the minus 34, and this is joule seconds. Divided by this 1.033 times the mass of the proton. Let's hop over to our constants. 1.67 times 10 to the minus 27. 1.67 times 10 to the minus 27 kilograms times the velocity of the proton, which is 0.25 times 3 times 10 to the 8th meters per second. All right, what does this wavelength work out to be? Let's stick in 6.626 e minus 34. Let's take in we got the 1.033, 1.67 e minus 27 kilograms, the 0.25, the 3e8, right? So lambda is Planck's constant divided by the gamma divided by the mass divided by the fractional speed of the speed of light divided by the speed of light. And 5.12 times 10 to the minus 15. 5.12 times 10 to the minus 15 meters, which is 5.12 femtometers. And that's the proton's wavelength. What is its kinetic energy, assuming it is non-relativistic? So kinetic energy, classical, is 1/2 mv squared, is 1/2 of the 1.67 times 10 to the minus 27 kilograms times 0.25 squared times 3 times 10 to the 8th, make that meters per second, squared. 1/2 mv squared equals, all right, so 1/2 mv squared is 0.5 times the mass of the proton times 0.25 squared times speed of light squared is 4.70 times 10 to the minus 12th joules. joules. Okay. And what is kinetic energy, assuming it is relativistic? Well, relativistically, kinetic energy is gamma minus 1 onto mass times c squared. In our case, we got 1.033 minus 1 onto 1.67 times 10 minus 27 kilograms. Times 3 times 10 to the 8th meters per second squared. All right. So in this case, it is gamma. Where's gamma? Gamma minus 1 all right, gamma minus 1 times the mass times the speed of light squared is 4.93 times 10 to the minus 12. And remember earlier I said it's about 3% relativistic. So if we look at 4.93 divided by, let's just go over to Excel to do this. If we look at 4.93 divided by 4.7, it's about a 5% effect. All right, about a 5% effect. Yeah. Okay. So 3 to 5% effect relativistically. And that's it for problem 6.